is the tank that's in fill, it's always looking at the of that tank, and it's looking at the level over the last however many minutes, let's say 30 minutes or so. And it's looking at the change in level over that 30 minutes. It knows the surface area of that tank, and so it calculates, based on that, an influent flow rate.
Yep, and I understand all that. Yep.
Compares that to the design flow rate and comes up with the percent of design. And based on that, it will use that percent of design to affect the anoxic time, the aeration time. It will continuously adjust those things and also look at hydraulic considerations to determine when it needs to take a tank out of aeration so that it's ready to go into fill, has time to go through, settle, and decant, and be ready to take fill before the tank that's currently in fill hits top water level.
Yeah,
and it's doing all that on a continuous basis. So when this is different than some older, simpler control strategies where you have regular mode and you have storm mode, right? And so basically, I think of it this way. What you're talking about there is like a two-speed bicycle, right? You've got normal speed and then you've got high speed. Normal mode and storm mode. But you got to think of flow proportional software or SBR logic software like a continuously variable transmission, if you're following my example here.
Completely following your example.
Right?
Yep.
So it's not like you're in one mode, you're in normal mode or storm mode. It's constantly calculating. If anything, there's like 300 different modes that it could be in. Am I at 2% of design or 20% of design or 57% of design or 130% of design? It's continuously going to be adjusting treatment steps and the length of each treatment step based on that percent of design. So a couple of things about this software. It is designed to not have to have any sort of influent equalization ahead of it, simply because it's designed to have one tank in fill at any given times. And one of the problems we run into, though, is if there is influent equalization, and if there are influent equalization pumps that are periodically run to feed the SBR, that can actually make it run worse if some of the settings are not set correctly. And the reason being is because the SBR software is calculating this influent flow rate based on the rise in level. If it's doing that when the influent pumps are off, well, it's going to say, oh, my flow's near zero. And then the pumps are going to come on, and it's going to say, oh, now my flow rate is 200% of design. Oh my gosh, I need to speed up the cycle because I'm at super high flow rates, and I need to shorten aeration, and I need to get it out of aeration and get another tank ready to go. So that can cause problems. Now there's a mitigating factor, which is we call it our samples set point, and that is the time frame over which the software will average out that influent flow rate calculation. And so what we recommend is if you do have influent pumps that are feeding an SBR, you want to make that samples set point long enough to where it will account for at least 2 cycles of those pumps coming on and going off. And that way it'll average out that influent flow over that time, and you won't see the spikes and the dips.
How many, the sample time, refresh me, and I think it's in the literature, but how many it is, I think it was a vague literature thing. It was like the number of 1 foot increment rises or something like that.
1 minute.
Oh, it's 1 minute. Okay, so 30 in that setting is 30 minutes.
Right.
Okay.
Which, if you have influent pumps that are feeding that SBR, that's probably way too short. Because if those things are coming on and off, say every if you get a start, say every 20 minutes, then during one 30-minute period, it may capture one pump start, and then a different 30-minute period, it could capture two of those, because it's a rolling average of the last 30 minutes. You see where I'm going?
Yeah, it's a lagged average filter. You get 30 samples in, but if you start up the SBR day one, it will take 30 minutes before it provides any output, and then that third. No.
It's not providing output immediately. It's just for the look at the previous minute, and then for the previous 29 minutes, it's going to say, oh, well, my change in level was 0 before that.
Right. Okay.
It just looks at the most recent 30 minutes, and then a minute later, it throws up the oldest reading, and it adds one new reading.
Yeah. Okay. We're saying the same thing. Lagged average filter. Yep. Okay. So that's something we need to check. We do have that scenario where we have a pump station but has VFD pumps, but nevertheless they kick on and off. What we do see though is that the tanks will have a fill top water elevation of 22 feet. The total is 24, so the tanks are 24 feet deep. Our top water elevation is set at 22. And when the sluice gates on the influent EQ tank are opened too much, or there's backed up flow in the influent EQ tank, it will move and it will think there's a high level condition, and it will fill the SBRs to 23 feet. If I read the literature, it says it will come 1 foot below the top. Well, so if we have the top set at 24 feet, it will come to 23 in that scenario, and that's what we're calling storm mode. And we're trying to figure out. In addition to this, was all very helpful. I think there's some other homework as well here, but we're trying to figure out what triggers that to go up to 20, to that that kind of a high flow scenario. Because I know you're saying it's graduating all the time, and that makes sense when it's in between the bottom water level and the top water level. Yes, it's fluctuating, increasing times, but whenever we get either the sluice gates are just opened up and there's some water backed up, because to the SBR it thinks it's a storm. It seems like, because the pumps just stay off. Yeah, the pumps never shut off in that scenario, right? So then they just keep running and keep running and keep running and keep running. So that average of the flow percentage, instead of going down every now and then, it just keeps going up, 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 up. And something then triggers that to go to that 23. Yep. There's some trying to understand the logic of what triggers what happens, or is there a percentage of flow? Or what is saying in the logic? Yeah, we're going to fill there seems to be a lot of flow here. We're going to fill these tanks up to 23 feet.
Right, got it, and I can see that. So let me ask this: how many SBRs do you have in the system?
Just 2. 2 means 2 tanks. One sequencing batch reactor, but 2 tanks, if that makes sense. It's not a single tank.
Mm-hmm. Plus an influent equalization basis.
That's right.
Okay. Well, in a 2-tank system, because of the limitations we talked about earlier, that one tank has to be in fill at any given time. The ideal scenario under normal flow conditions would be, as one tank goes through an oxic fill, an aerated fill, the other tank is 180 degrees off on its cycle, so it's going through react, settle, and decant, and hopefully has time for idle.
Right.
And then, once one tank ends fill, they kind of flip, and now that tank is going through react, settle, and decant, while the other tank is going through an oxic fill and aerated fill. But the problem is, when you get into high flow conditions, there's only so much that the system can do to compensate for those high flow conditions. One of the things it's going to try to do, like I mentioned earlier, is try to get a tank out of fill. I'm sorry, get a tank out of aeration. When a tank is in fill, what it's doing is it's calculating time to top water level.
Yep.
What it's doing as it's calculating the influent flow rate, like we talked about before, and it's using that number to say, at this flow rate, how many minutes is it going to take before this tank that's in fill reaches top water level? And then so it says, okay, whatever that number is, 40 minutes, 50 minutes, 60 minutes, this is how long it's going to take for this tank to get to top water level. I need to make sure then that the other tank, I would like it to be in idle by the time that this tank reaches top water level. But it can't shorten settle. Settle is a set amount of time.
Yep.
It can't really shorten decant, because what we're trying to do in decant is get down to
bottom water level. Yep.
So the best it can do is kick a tank out of aeration sooner than it normally would based on aeration time set points. And the way it does that is it says, if my time to top water level is less than my settle set point plus my settle safety set point, I'll kick a tank out of aeration, even though it may not have reached its aeration time. And it does that in an attempt to have that tank, give that tank enough time to get through settle, get through decant, and be in idle to be ready to take fill before the tank that's in fill hits top water level. Now, it can only do so much, because once it kicks that other tank out of aeration and into settle, there's nothing more it can do. And then if your influent flow rate increases even more, the water's got to go somewhere. And so a choice has to be made. Is it better to take that influent that's coming in and put it in a tank that's at top water level? Or is it better to put it into a tank that's in settle or decant? Well, our decision in the software says we're going to allow the operators to put a buffer in there above top water level to say, as long as we're within that buffer, we're going to still keep putting influent into the tank that's in fill rather than switch and put it into a tank that's in settle or decant. And that buffer is defined by your software top water level. I'm sorry, software emergency top water level. So if you've read through the literature, you've probably seen reference to an emergency top water level set point.
Yeah,
sometimes
which is
it's called software emergency top water level. It used to be called wall height, which was a bad, confusing term.
Yeah, ours is called wall height, and our literature says that the emergency top water level is 1 foot below wall height. So we have.
You must have an older system. How old is this?
It was put in 2006.
So it's quite old. Okay.
Yeah.
So we changed the way the set point works the same, but we just call it something different rather than saying,
"Yeah, I
you
understand.
tell us how tall your wall is, and then we'll just assume that we can go 1 foot below that."
Yep.
We thought that was confusing, and so we said, no. Nowadays, we just call it software ETWL, and you set it exactly where the highest point is that you want to be able to fill that tank. So if you've got an old system, yes, you will put in wall height. But whatever you put in, it will subtract a foot from that and say, that defines my buffer. That defines how much higher over top water level I can go in these extremely high flow situations. I'm going to use that space above top water level rather than put fill into a tank that's in settle or decant.
Yeah. Okay, that makes sense. I understand. So we're basically getting up against it's thinking. It takes a little bit of time for me to think through that a little bit, but fine. It's thinking to that it has more flow. There's no time. It's still waiting for the other tank to get through settle, decant. There's not going to be any idle time, so there's no wasting.
Right.
And it's like, I still got flow. I got to flip this. Basically it says I'm nearing 22 feet in our scenario. I'm just going to keep filling because this other one's not ready yet. So we've backed out. Yeah. We have no idle time. We have no other time. It's just going to keep filling that tank. It will fill up to 23.
If you have your wall height set at 24,
yeah, yes, it'll fill up to 23, and then after that.
Well, so that is the point at which it says, well, I can't fill this tank anymore. I've got to switch over to filling the tank.
So it goes to like fill. Yeah, it goes to a filled.
Settle or filled decant.
Right. Okay.
Which is not ideal, and we're trying to avoid that as much as possible. But we can't fill more than we can't go over wall height.
Yeah, which makes sense, and that I've seen that, and that makes sense. I've seen it go into filled settle and filled decant. I swear it didn't fill the other tank to 23 feet first, but I wasn't. Maybe I'm wrong because I'd have changed. Maybe that's a different graph. Maybe I didn't look.
So one of the things I would recommend that you look at is I don't know if you have a trend chart you can look at, or
yep, we do.
An event log where you can look at on your influent pumps to see how often they're cycling on and off. But one of the things you could do is increase that samples set point to get two starts and stop cycles in on your influent pumps. And what that may do is hopefully give you a better picture of what your influent EQ is. Is this a situation where, like in the mornings, you see flow rates go from real low to real high rather quickly? Or is it during rain events?
No, it's rain events and or in operations now, they'll choke down the sluice gates to slow down flow going through the SBR. And the influent EQ helps with the sluice gates because it's just basically a giant pump station. It's a pump station with a gigantic wet well when the sluice gates are all the way open. If they're choked down, then they're feeding a constant little bit of flow to the pump station, right? Because there'll be backed up flow in the influent EQ. So theoretically, when they are choked down, the pumps in the pump station are running at a pretty regular cycle.
And then that's what the SBR's like. SBR's, they'll run best when they have a nice constant flow.
So that's the trick is, are they running at a pretty regular cycle, I guess, when they're choked down? Is it, with the VFD, is it a scenario where if we're choking down the sluice gates and it is running at, which is a fine line, right? It is running at a nice steady cycle, or the pumps, then the pump station should just be constantly on. One of those pumps, they should, especially with a VFD, it should just be.
The VFD should ramp up and down to accommodate the level, but
yeah, it would just be constant. There's like pump one would turn on. It would theoretically it could be on for months if you have a nice steady flow. But to say, well, that's probably happening. I was like, well, I'd want to verify that. I don't think that's the scenario. I think that pump station's turning on and off. The sampling, now that I understand the sampling a little bit more, because in the literature, the way it said it, I was like, what the hell does that? It's one of those things that you have to read it like 4 times. I'm like, I still don't know what that means. The number of minutes for a 1 foot fill. I'm like, what? Well, and I sent it back to Dan, and I do need to get updated literature from him, because it seems like it was, but it was called Willow Hollow. But then when I looked at the Willow Hollow, it's talking about DO probes and stuff. We don't have any of that. We're just running on a time. It's all timer based. So I don't know. Yeah, I really do want to add DO, but we have bigger fish to fry. I'd like to add. I have it all set up. We have a YSI controller now, and it's just money. For another 10 grand, I could get DO probes in there and just start running this all.
Can I speak for a minute on that? To me, putting DO on an SBR plant that's going to make it run so much better, because what you're dealing with in these rain events is a higher volume of liquid coming in, but not necessarily a higher volume of loading. And in instances like that, if the control system knows what the DO level is,
yeah, it just keeps it.
We put set points in there to say, hey, once your DO gets above 3.5 or 4, get out of aeration.
Yeah.
There's no reason, because it's just rainwater. And it's probably got high DO coming in the first place. And so you can speed your cycles up way more and get the hydraulic load through there and not sacrifice any of your treatment.
Well,
and the whole system runs a lot better.
Well, right, and that's where I was at. I'm glad you said that. I'm going to convey this sentiment to the operator, because they were, as I'm looking through the literature. I mean, SBRs are feast famine machines. That's all sewer is, right? And it's really based on DO. And instead of all this timing and blah 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 to guess if you're getting the right DO, it's so much simpler to just put a DO probe in and then say go between these controls. Like, you're not guessing, are we in anoxic? I don't know. Is the timing right? Do we have to, you'll just know. Yeah. Like, you can chart it and see, yes, we are definitely in anoxic.
And DO probes are way more reliable and more rugged than they used to be. And so, yeah, ICI is a good brand. Swan, Hawk, there's a lot of good brands out there. So if you do go that route, let us know, because we can easily incorporate that into the control system and tune that thing in to run a lot better during these storm events.
Agreed. So we re-rated the plant, I don't know, a decade ago. And we went from 300,000 gallons a day to 374,000 gallons a day. The flow rate of the plant still set at like 206 gallons per minute, which is not equivalent to 374. That's equivalent to 300,000 gallons a day. It crossed my mind of, should we be setting that to the actual design flow rate? I don't know that it really matters. It's not that much of a difference between the two. Is there any thoughts you have on that? Yes, no?
Well, it's...
because it's comparing the influent flow to that number, right? And that's how it's doing a percent of flow. So it's going to impact the thing. Yeah.
Right, but then what does that mean when you say what is a plant designed for? That you're talking about
hydraulic
tank size, you're talking about blower size, pounds of oxygen that go in there. So when you say you re-rated it, was anything physically changed in the plant?
No.
Like your tanks got taller.
No.
I doubt if you changed your blowers out.
No, Avaqua went back through basically Avaqua did the study, and I'd have to go back into the study to look at the conclusions of how they determined it could handle up to 374. Maybe there was some safety factor, or a little bit more conservativeness that they felt was not needed. But I guess I was at so nothing physical changed. I mean, the influent EQ did change. Maybe that was a part of it. It got bigger. But I noticed the difference, but I ultimately came to the conclusion, well, the number's not that much different. I don't think it's going to hurt that it's set to 206, but maybe it does. I don't know.
I would agree with you that it's not going to hurt that much, but it also wouldn't hurt to change it. It would give you a more accurate
percent of flow,
knowing that, hey, I'm at 100% of design, therefore I'm going to get this much aeration and this much anoxic time and that sort of thing. And then the other thing that factors into that is knowing, let me put it this way, at 100% of design, when a tank goes into fill and starts at bottom water level, then it should reach top water level at its max fill time. Right? I'm assuming your max fill time is probably 180.
Yep.
So then if we were to take top water level minus bottom water level and figure out what the volume of one batch is based on that, then that volume divided by 180 minutes that's what your design flow rate should be. And if they said, oh, well, your design flow rate is actually higher now, well, what you may be able to do is move your top or bottom water level set point to make your batch size a little bit larger.
Gotcha. Yeah. So what we're struggling with mostly, it's not the plant has plenty of capacity. We're only it's a 374,000 gallons a day hydraulic capacity plant. We're only running at like 90 to 100,000 gallons a day. Yeah, it's not. We're a third of the capacity. So capacity is not so much our issue. Really, what the operations is struggling with is keeping consistent settling, which is a whole different ball of wax. But just so we get good decants with clear liquid and the TSS level isn't really high and things like that. We have a downstream sand filter. It gets kind of messy. So right now the bottom water level is at like 19.8, and that usually is been trending up. It really should be down at 17. It's been trending up because obviously a way to make sure the decants are clean is move that bottom water level up, right? Because then the decant arm doesn't go. So we have these kind of smaller batches, more frequent, I would say, I guess. Yeah, ish. Yeah, more frequent, smaller batches. Because the settleability isn't there. There's been other things we've been dealing with, mechanical stuff, a lot of things. But now that we're, God willing, getting through all that stuff, I'm really trying to focus on honing this thing in. It was honed in, all through June. Then there was a hiccup at the end of June. Then most of July and all August, it was tuned in really well. And then there was another high flow event last Friday, and it put it into this storm mode, which really isn't. There isn't a storm mode. We need to get that literature off. There's no such thing as a storm mode.
You won't see the word storm mode in the literature anywhere.
One thing do you guys have any kind of Excel spreadsheet that shows? I did receive something from Avaqua a while ago, and I was working on something. I think I even sent it to Dan, trying to see, if we could say, okay, if you type in this, it should change these times to this, because there's there's an air slope and so on and so forth. Is there anything like that you guys have, or is it?
Yes. I mean, that's something that one of the techs at Avaqua came up with a while back. I'd have to dig for that, but I could probably find that spreadsheet that would allow you to put in all your set points, and then when you choose a specific flow rate for that design, it'll show you how much time you're going to get in anoxic and in aeration and react and that sort of thing.
So we received something from Avaqua. I used that as a base, but it was very cryptic too. You know what I mean? So if you don't
have anything that's less cryptic.
Yeah, it was still pretty cryptic. And then they talked about like dog watch time and things. I'm like, what the heck is dog watch time? So I don't know if that's a term you know of.
A watchdog timer?
Watchdog, yeah, watchdog timer. Yeah, sorry, not dog watch.
Well, I know what that is, but I don't know how it affects a system like this. Huh.
Yeah, that's why I was like, was kind of. Did anybody ever say, "Oh yeah"? Some Mike, I think it was, sent me this, a year ago, and then I'm like, this watchdog time. I'm like, what's that? It has nothing to do with this. And I'm like, I'm all confused because if this is supposed to be our system, there's stuff in here that I don't understand. So, if you don't mind, can I send you what I have and then look at it? And then if you have something better, or you could say, yeah, you can disregard this watchdog time thing. That has nothing to do with nothing. And
yeah.
And just look at, you can look at the cells. I've been trying to I'm trying to make it real simple. I have screenshots in Excel of our controller, like our set points. And then below it, you can type those things in, right? So you can see like in a matching terminology. And then I have a chart, which I want to see like, okay, if you adjust these things to this is how it will affect things. Because then there's mins and maxes. So we can see like, yeah, these when you put in these mins and maxes, all this other stuff is irrelevant because your air slope doesn't matter anymore because your min is so high. Yeah, you can constrain it so much that other parameters are irrelevant. So, and to me, I kind of need it, and it's not like you can just fiddle with this stuff on the controller to see.
You need to know what you're
doing. Yeah, the control, the live sewage process with the controller is nowhere to be playing. But with the Excel, I'm trying to get to a spot so somebody can like, this is right. I would love, once we get it, like to work with you guys on it. Like, this is correct for your logic and your controller. This is how it works. And then I can use it ourselves and send it to the operator and say, before you put stuff in, put it into here, and vice versa. I can check settings like, oh, I saw this setting change. I want to type that into Excel. Like, are there secondary effects that we're not thinking about that become apparent? Or if it's like, well, I did this, but I don't understand why it's now doing this. It's like, well, did you put it in Excel? Because then you can just look at the equations and see what's happening, like why it's, you know what I mean? I just think it can be useful.
Yeah, I know what you mean. I'm happy to assist. If you want to send me that spreadsheet, I can take a look at it and see if we have something better. I will say this: we can help you understand your control system a lot better. However, since I am a controls engineer and not a process engineer, when it comes, I've experience,
yep,
but I've never run a plant myself, so I can tell you what your control system is going to do. I'm not comfortable saying, oh, well, here's how you should run your plant.
No, I'm not expecting that.
Okay, well, let me give you my email address, and you can send me what you have, and then if I have something better, I'll send that your way.
Yeah, I have yours. Dan included you on it. I'll fire this stuff off to you. I'll fire the original thing I got from Avaqua, and then I'll fire you. And also attached to that will be how I've taken that and tried to simplify it and customize the control. Really, I was getting hung up on is the watchdog time thing. I was like, I don't even know what that is. The literature doesn't talk about it, but and maybe they fired something to the operator that was some other plant, but it was something close, and it's like, well, I don't need close. I only need it to be right on.
Absolutely. Okay. Well, send it on over, and I'll take a look at it.
Sounds great. Thank you so much for your time today.
You're welcome. All right. Talk soon.